The tempestuous computer technology development and its application in various activities have led to an inability of teaching future professionals in higher education institutions without computer training systems. Today, developing the computer distance learning system, shortened DLS, and methods of its use is an important task. Besides, DLS may become a basis for an intelligent training system for combat-ready service personnel, the system that meets the purpose the best. Due to the increasing complexity and information density of different professional training methods, arises need for effective management of the learning process. As the training system becomes more complex, multifunctional, and is designed for different categories of users, there is a need for adapting it to each user's characteristics. The ability of adapting DLS to the users is one of indicators of its effectiveness and, as a consequence, of its intelligence. To ensure this user adaptation are developed models of the trainee which store information about each user. Thus, today, DLS acquires more complex structure and includes not only a description of the training material, but also information about users and the learning management process. We need to determine a rational option for the DLS construction that provides training of future professionals of the highest possible education level in the shortest time. The solution to this problem is possible by the use of modern intensive training technologies. In this case, intensive technology is defined as a system of factors that intensify the learning process, ideal, aimed for increasing the activity of trainees, and material or technical that provide maximum level of training in the shortest time. The tasks of the first group, the analysis of DLS, are characterized by the following two stages of research. The first stage connects with building a conceptual model of DLS operation, and the second stage connects with building the dynamic adaptive controlled process mathematical method, which is created on the basis of the accepted conceptual model. The dynamic adaptive control process consists of the object of management, future specialists, controlled parameters, trainees' activities, quality indicators, control influences, educational tasks, or shortened ET, formed by intellectual CBLS. The algorithm for controlling the learning process, the algorithm for changing the intensify of the ET in accordance with the level of future professionals' training. In addition, the system of indicators and methods for assessing the effectiveness of intelligent CBLS are also being developed. The analysis provided within the framework of the DLS construction theory show processes, models, its functioning, and regularities which are inherent in these processes or system in general. The basis of the proposed methodological intensification approach is that the inner conviction of future professionals in the limited time left to study and perform the educational task causes them a state of tension. If the tension does not exceed the limit value V, the maximum allowable tension, the impact becomes organizing. In the DLS functioning model, the tension is defined as the internal state of the J specialist immediately before the execution of the I elementary task. The concept of tension is implemented in DLS by reducing the cycle of educational information display on PC monitors until the tension reaches a given level V, at which the lack of time acts as an organizing factor. The organizing influence of emotional tension is determined by the fact that in the learning process, specialists work more focused and more precisely, and the probability of correct and timely execution of ET increases. The attention function is the ratio of the time acquired to complete the training task to the actual available time that have specialists in each cycle of DLS, as you can see it on formula number 1. In general case, the problem of intensive training is as follows. To find from the set of possible options such a variant of construction DLS which provides intensive future professionals training to the required level with minimal financial and time costs. The formal statement of the scientific problem is presented in the form of a solution to the following problem shown in formula number 2. As we see from this formula, all the criteria are contradictory, and it is extremely difficult to find the best option for constructing a DLS that satisfies all the above conditions without the development of methodological such systems, constructions, bases, structure, optimization methods, and parameters of DLS. The decision of the specified problem is impossible. The conceptual basis for the intensive training DLS construction is a combined solution of the following two main tasks: accelerated specialist training to the required level of the educational tasks implementation with the minimal time costs, training of specialists to perform tasks up to the maximum possible level of professional training with given time constraints during the planned training sessions. Thus, implementation of intensive learning technology closely connected with an adaptive change of the educational tasks speed issuing from the teacher's PC to the trainee PC. The method of solving the parametric synthesis problem includes the following main stages. First, the efficiency indicators of each option's constructing DLS on a set of system functioning conditions to select the best of them are determined. As the second stage, the problem of situations classification of the satisfaction basis with the accepted restriction is solved. Under the situation in the multi-dimensional factor space means a solution, as well as the conditions of its implementation. For each situation's point, performance indicators are calculated and the obtained values are compared with the allowable ones. Methodological basis of requirements substantiation to DLS are based on the methodology of their synthesis and include the decision of the third problems group, training level dynamics modeling in the course of future experts' preparation and according to the received indicators of target and economic efficiency, so requirements to DLS construction are formulated. Also, the requirements for DLS architecture, knowledge base, expert subsystems of objective control, planning and management of training and information environment, hardware and software of all DLS subsystems are substantiated. The fourth group of tasks involves the development of DLS construction technical principles, for example, technical solutions that will ensure the implementation of reasonable requirements for them. A conceptual point of view shows DLS is an integrated intellectual adaptive system that first studies educational tasks and then, with the help of artificial intelligence elements and the stage of initial training, educates specialists to perform these tasks. As the necessary skills and workabilities are learned, the information support of artificial intelligence changes adaptively. Let's have a look on the main stages of organization and specialist training using adaptive training tools to substantiate the goals of the training process adaptive management. At the first stage, the goals and tasks of training are formulated. The ultimate goal of such training is to educate staff to the required level, which ensures the implementation of educational tasks in the most difficult conditions, in order to achieve by trainers a training level that allows timely and error-free do ET operations in the most difficult conditions. It is necessary, based on the actual level of the study, to determine for each training dose progressive intensity of simulated situations exponentially. Thus, the ultimate goal of training is to achieve by staff the required level of training to perform basic ET operations types at a given intensity of simulation situations. In the second stage, as shown in figure 1, the required predicted levels of staff training to perform the main ET operations types are determined the following way. At the third stage of the organization and providing staff training, a situation in accordance to design in advance the optimum plan of intensive preparation is simulated. In order to make the simulated situation as close as possible to the real one, it is necessary to use a set of such situations that took place in the staff work or may arise in conflict situations. Direct testing of ET operations main types is carried out in the fourth stage, the sense of which is as follows. In the process of simulating circumstances, the staff performs a finite number of operations types and at the same time, depending on the level of staff training to perform standard operations, a certain type of situations that required intervention in the staff management process is created. In other words, a simulated circumstance in a source of information for staff using which they assess the situation, make decisions, and perform appropriate operations types of the training task. In the process of standard operations, realization by staff, an adaptive change of circumstances is taken place. For example, adjusting the number of simulated situations depending on the staff training level to perform standard operations. At the same time, there is an objective control over the staff work. The assessment of the staff training level is based on the analysis of probabilistic characteristics which take into account the accuracy and timing of the operations, main types, and ET in general. The first stage of the training organization and carrying out, it is necessary to adapt parameters of the simulated circumstances, the minimum required number of situations, and the average time of staff training due to the changes in the actual level of staff training. This simple adaptive control cycle of situation simulating process is the lower adaptation level of the organizing and conducting training process. At this level, an adaptive change of the simulated circumstance is provided depending on the level of staff training to perform each ET operations type. The main purpose of the circumstances simulating process adaptive management is to minimize the time of staff training for the required predictable levels to perform the main ET operations types. Thus, adaptive control of the circumstance simulation process consists in change of the simulated situations, perimeters, and accordingly working off operation each type for the minimum time intervals. If the lower limit of process adaptation is not effective enough, for example, conditions and are not constantly met, it is advisable based on the actual level of staff training to adjust training objectives and then the corresponding indicators of predicted levels and average training time. This cycle of the circumstances simulating adaptive process control belongs to the upper level of training processes adaptation. So conclusions. Thus, in the article are proposed ways to solve this scientific problem of building and organizing the DLS functioning with artificial intelligence elements for training specialists with using simulators or intelligent computer training systems for practical and laboratory classes. The requirements to the intellectual DLS are substantiated by the structural and parametric synthesis, problems solving and organization of the optimum functioning in the training course with using the offered criteria. The algorithm for the adaptive management organization of specialist training process using the predicted training levels in order to reduce training time was offered for training staff with using of adaptive training tools. Thank you for your attention.